Day 1, Problem 1. Part A, rewrite the number into standard form. And we have this number here, which is in scientific notation, and we're asked to write this as a standard number, a regular number. The way we're going to do that is by manipulating this decimal point. We're going to move this decimal point according to what the exponent on the times 10 part indicates. And in this particular problem, the exponent on the times 10 piece is -4. And so how I'm going to do this is by first writing the problem down again, 2.158. And now the scientific notation part is the times 10 to the -4. Okay. Now, to do this problem, we need to realize what a negative exponent means. So just as an aside, if we had 10 to the -1 power, the meaning of that is the fraction 1 over 10 to the first power, or 1/10. 10 to the -1 power is another way of writing the fraction 1/10. Now, 10 to the -2 power is equivalent to the fraction 1 over 10 to the 2. Or another way of writing this would be 1 over 100, the fraction 1/100th. And then 10 to the -3 power would be 1 over 10 to the 3rd power, and so on. Now, what happens to any number like 2.158 if we multiply it by 10 to the -4 power, remembering that negative exponents produce fractions? If you multiply numbers by fractions, the numbers get smaller. Okay? If we multiply this number by 10 to the -1 power, that would be like multiplying it by 1/10. And the effect of that on the decimal point is to move that decimal point one position to the left, creating 0.2158, which is a smaller number than this. Okay? But that's if we multiplied by 10 to the -1 power and only moved one position to the left because of a -1 power. In our question, our exponent is 10 to the -4 power. So we are going to move the decimal point. We are going to move the decimal point to the left, creating smaller number than what's written here, but not one position to the left, instead 4 positions to the left. Okay, let's do that. 1, 2, this is going to need to be filled in with a 0. 3, this will need to be filled in with a 0. And 4, and this spot again will need to be filled in with a 0, and the decimal point will end up out here to the left. And so that number is going to be point, and then 0, 0, 0, and then the 2158. So 0.0002158 is the standard way of writing 2.158 times 10 to the -4th power. Now part B. Rewrite the number into scientific notation, and here's the number. So I'm going to rewrite that number, 0.000831, and rewrite it so that it has a number at the beginning, and it has a times 10, and it has some sort of exponent on the 10. Now remember, in scientific notation, we want to have only one digit to the left of the dot. We want the dot to be here so that only the number 8 is to the left of the dot, instead of there being other, multiple numbers to the left of the dot. We just want to have one number to the left of the dot. And so that means we want to move this dot from where it is to this position here. Let's keep track of how far we have to move the dot. 1, 2, 3, 4 spots. And we will create 8.31. Okay, now the scientific notation piece of this, times 10, and there will be some exponent on the 10. Now remember that we moved 4 positions, and so if we use an exponent of 4, let's think about what this would create. Multiplying by 10 to the 4th power is like multiplying by the number 100,000. 10 to the fourth power, I'm sorry, not 100,000, 10,000. 10 to the fourth power is the same thing as 10,000. If we multiply 8.31 by 10,000, we get a much larger number. That's not what we had to begin with. So it's not 10 to the fourth power that we want to have as our exponent. It is actually 10 to the negative fourth power. Again, a negative exponent manipulates the decimal point by moving it to the left 4 spots, and that's how it could end up being 0.000831, which is what this number was. So 8.31 times 10 to the negative fourth power is the scientific notation version of this number here. Now, day 1, problem 2. Part A, solve the equation. And then we have an equation here. We would like to solve this for x. And then in part B, check our answer and make sure that we have the right value for x. So I'm going to rewrite the equation. 2 times the quantity x minus 3 is equal to negative 15. One way to go about doing this problem is to multiply the number 2 by this number and by this number in the parentheses. That is called the distributive property. So let's do that. I'm going to draw a vertical line to help keep the left side of the equation separate from the right side, and then multiply 2 to the x, and then after that multiply the 2 to the 3. 2 times x is 2x, and 2 times 3 is 6. In front of that 3, a subtraction symbol is being used to separate these terms, and so let's continue to use a subtraction symbol to separate these terms as well. 2 times 3 is 6, and that is equal to negative 15. Now we want to solve for x, so we need to get the x term alone. Here's the x term, and next to that x term is a subtract 6. So let's remove the subtract 6. Under it, I'm going to write add 6, and the same on the right side of the equation. The 2x can be brought straight down. Negative 6 plus 6 makes 0. There's a 0 in this position. And that is equal to negative 15 add 6. That is negative 9. So now we have 2x is equal to negative 9. Okay. This says 2 times x. We can remove the timesing by 2 by using division. So underneath, divide 2, and over here, divide 2. 2 divided by 2 makes 1, so 1x is equal to negative 9 divided by 2 is negative 4.5, or as a mixed number, negative 4.5. Either is fine. And 1x is the same thing as just x. So x is equal to negative 4.5. This is the value that we think is correct for x. And in part B, we are asked to check that value. So if we use negative 4.5 in place of the x in this position and work out this expression, does it truly equal to negative 15? And if it does, then we have the correct answer. So 2 parentheses, and then for the letter x, substitute in the value that we think is correct, negative 4.5. Subtract 3, parentheses, and then equals negative 15. Now on the left side of the equation, we have this expression. Let's work out what this is equal to and see if it does in fact equal to negative 15. So following the order of operations, we do whatever is in the parentheses first, and that is this piece right here. So we have 2 parentheses, and negative 4.5 subtract 3 makes negative 7.5. And is that equal to negative 15, we wonder? Okay. Now the multiplication, 2 times negative 7.5. Well, a positive number times a negative number creates a negative number, and 2 times 7.5. So 7.5 plus another 7.5 is negative 15. And that is equal to negative 15. So are they the same? Yes, they are. And this problem checks. The answer x equals negative 4.5 is the correct value for x.